Today we're going to be finding slope given 2 points using an equation that is derived from the definition of slope, which is the change in y's divided by the change in x's. So that equation is this. So the change in y's, meaning the second y coordinate subtracting the first y coordinate from it, divided by the second x coordinate subtracting the first x coordinate from it. Okay, and I think the most difficult part sometimes for students is knowing where those x sub 1, x sub 2, y sub 1, and y sub 2 come from. Guys, those are just labels for any set of points on a line. So if given 2 points, we can kind of substitute in x sub 1, y sub 1, x sub 2, y sub 2 into this little equation here, and it will give us a slope if we simplify and solve. So in this first problem here, if we're given 4, -6 and -1, 2 as our 2 points, and we're trying to find the slope, well, let's first label 4, -6 and -1, 2 as x sub 1, y sub 1, x sub 2, y sub 2. Does it matter if your first point is x sub 1, y sub 1, your second point is x sub 2, y sub 2? No, you could actually flip-flop these and you'd still end up getting the same answer. But I like to stay consistent, so I'm going to label the point that appears first as x sub 1, y sub 1, and the second point x sub 2, y sub 2. So once we have these labeled, we can kind of insert or substitute these values into my equation. So instead of y sub 2 minus y sub 1, I'm going to write 2 minus -6. And instead of x sub 1 and x sub 2, I'm going to write -1 minus 4. So then all I have to do from here is just kind of simplify. Just be careful when you subtract a negative number. It's kind of like adding that number. So 2 minus a -6 is 8. 2 minus -6 is 2 plus 6, which is 8. And then a -1 minus 4. So if you owe me $1, then you owe me 4 more. You owe me a total of $5. So the slope to this line is a -8/5. So my m would equal -8/5. In the second problem, we're trying to find the same thing. We're trying to find slope. Okay, so first up, I'm going to label my x sub 1, y sub 1, and x sub 2, y sub 2. This time, though, I'm going to label it out of order. I'm going to label the second point here that appears as x sub 1, y sub 1. And once again, guys, this isn't going to end up mattering because of that subtraction of the change in my y's over the change in the x's. It doesn't matter which order you put them in. But what matters is that we stay consistent. So when I plug these into the equation, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. When I substitute these in, I got to make sure my x sub 2 goes where x sub 2 goes, and y sub 2 goes where y sub 2 goes, and so on and so forth. So I'm going to substitute in a 1 minus a -7 on top. And on the denominator, we're going to have x sub 2, which is 2, minus an x sub 1, which is a -6. We're going to have subtraction of a negative again, so we got to be careful. So 1 minus a -7. Going to give me a +8, and then 2 minus a -6 gives me another +8. So I do have a slope of 8/8, but I know I can reduce this fraction down to 1/1 or just 1. So make sure you tell me that your slope is 1 and not 8/8. We want to make sure we're simplifying those fractions where we can. So there's 2 examples for you guys on how to kind of properly use that m is equal to the change in y's over the change in x's equation to find the slope of a line.